Statistic business presentation about dot plot. Dot plot meaning. A dot plot, also known as a dot diagram, is a statistical chart consisting of data points on a relative simple scale. Dot plots are considered as one of the easiest statistical plots. Used for small data sets. Dot plots are used for highlighting clusters, gaps, skews in distribution, and outliers. When working with data sets larger than 20 or 30, it is better to use another statistical chart, such as a histogram, as the dot plot will be less manageable. How to make a dot chart? While constructing a dot diagram, data points are stacked in a column over a category. The height of the column denotes the frequency of observation in a given category. The categories of dot diagram given below are the numbers from 0 to 9, where 0, 1, and 5 occur 3 times, 2 occur 7 times, 3 and 4 occur 6 times, 6 occur 4 times, 7 and 9 occurs 9 times, and 8 occur 2 times. The dot diagrams given above represent the total number of data points and how the data points are distributed among certain categories. To make it easier for us to understand, now I will explain step by step to make a dot chart. For example, the service departments at Stafford Lincoln Mercury and Sheffield Motor Inc., 2 of the 4 Applewood Auto Group dealerships, were both open 24 working days last month. Listed below is the number of vehicles serviced last month at the 2 dealerships. Construct dot plots and report summary statistics to compare the 2 dealerships. The Minitab system provides a dot plot and output the mean, median, maximum, and minimum values, and the standard deviation for the number of cars serviced at both of the dealership over the last 24 working days. The dot plots shown in the center of the software output graphically illustrate the distribution for both dealerships. The plots show the difference in the location and dispersion of the observation. By looking at the dot plots, we can see that the number of vehicles serviced at the Sheffield dealerships is more widely dispersed and has a larger mean than at the Tionsta dealerships. Several other figures of the number of vehicles serviced are: Tionsta serviced the fewest cars in any day, 23. Sheffield serviced 26 cars during their slowest day, which is 4 cars less than the next slowest day. Tionsta serviced exactly 32 cars on 4 different days. The numbers of cars serviced cluster around 36 for Sheffield and 32 for Tionsta. From the descriptive statistics, we see that Sheffield serviced a mean of 35.83 vehicles per day. Tionsta serviced a mean of 31.292 vehicles per day during the same period. So, Sheffield typically services 4.54 more vehicles per day. There is also more dispersion or variation in the daily number of vehicles serviced at Sheffield than at Tionsta. How do we know this? The standard deviation is larger at Sheffield, 4.96 vehicles per day, than at Tionsta, 4.112 cars per day. Interpreting dot plots and assessing the distribution of your data. Dot plot display the distribution of your data. Look at the central tendency, variation, and overall shape of the distribution. You may create a dot plot before or in conjunction with an analysis to help confirm assumption and guide further study. Center and variability. The tallest stocks of dots represent the most common values in your dataset. This region is where most values tend to fail. It is the central tendency of your dataset. The width of the distribution indicates the amount of the variability. Broader distribution signify greater variability. In the dot plot below, the center is near 50. Most values are close to 50, and values further away are rare. Develop an idea of the data's variability by looking at the distance between the minimum and the maximum bins. In this dot plot, the two distributions both center on 50. However, the spread of values is notably different. The values group A mostly fail between 40 to 60, while for group B, the range is 20 to 90. Skewed distributions. Determine whether your data tapers off symmetrically from the center or if it is skewed. The height data follow a roughly symmetric distribution. In right skewed distributions, most values fall on the left side on the distribution, and a long tail stretches to the right. As you guys can see, most of the body fat percentages are relatively low, with a few that are unusually high. Conversely, for the left skewed distributions, most values fall on the right side of the distribution, and long tail rises for the left side. Dot plots are a simple but effective way to identify outliers. Just look for the values that stand out from the others. After you find them, you'll need to decide what to do with them. Multimodal distributions have more than one peak. This type of distribution stands out in a dot plot, but it can be easy to miss if you focus on summary statistics, such as a mean and standard deviation. There are two types of dot plot. The first one is Wilkinson dot plot. The Wilkinson dot plot represents the distribution of continuous data points, like a histogram. For example, the temperature in a room through the day. A histogram is shown in Wilkinson dot plot, but represents the individual data points, like P, Q, R, S shown below rather than bins. These points can consider any values like mathematics mark of 4 friends, or the numbers of minutes taken by 4 kids to finish their lunch. The second is Cleveland dot plot. Cleveland dot plot is a good alternative to a simple bar chart, specifically if you have more than a few items. It doesn't take much for a graph to look cluttered. In the same amount of space, many more values can be plotted in a dot plot, and it's easier to read as well. Although this type of dot plot is similar to a bar chart, but uses location rather than the duration of the data and counting values. Just like the height of the bar chart represents the number of items, the position of dots in the graph represents the number of items for that category or bin. For example, the Cleveland dot plot given below represents the trend in literacy rate in post-independent India. Analyzing dot plot. A dot plot or dot diagram consists of a horizontal scale, a number line on which dots are arranged to represent the numerical values of the data set. If the values in a data set repeat, the dots are accumulated at that location. One dot is plotted for each repetition. We can say that dot diagrams represent the distribution of data. Analyzing the dot plot of a given data set can be done easily in a comparison to a long list of numbers. By looking at the dot plot diagram given below, you can see that the dots are evenly spread with a peak at around 8 letters. The center of the graph is between 6 and 7 letters. The dots are spread from 3 to 9 letters. With a dot plot, you can easily count the number of times each category or number is repeated. A dot plot is an optimum way of organizing number and values. Now I will give some example to help you guys understand how to analyze using dot plot. First example, as you guys can see, the dot plot given below represent the numbers and types of pizza ordered for the party. By analyzing the dot plot, determine the number of pizza ordered for the party and how many of these pizza were pepperoni or cheese. Solution: to determine the number of pizza ordered for the party, add all of the data points together on a dot plot. In total, 22 pizza were ordered for the party. To find the number of pizza ordered for a certain category, zoom up all the points in those categories. There are 7 pepperoni pizza and 5 cheese pizza. In total, 12 pizza are of cheese or pepperoni. Second example, as you guys can see, the dot plot given below represent the height of each kid at Mr. George's daycare. Each dot represent the height of different kids. Determine the height of the shortest kid. Solution: the height range of the axis is from 83 to 86. The 3 dots are plotted on the bin 83, which implies that 3 kids whose height is 83. Therefore, the height of the shortest kid is 83. That's all for my presentation. Hope you guys can understand. Thank you.